Okay, today we're going to review how to do some basic factoring. In order to do some questions that we're going to look at in this unit, you have to be able to do some greatest common factoring, and you have to be able to do some difference of squares factoring. So we're going to review both of those today. So we'll review both quickly and just kind of remind you how to do some of this stuff. So if we have two things, let's just look at some basic numbers. If I gave you 8 and 12, right, both of these things would, the greatest common factor would be 4, right? 8 divides by 1 and 8, 2 and 4. 12 divides by 1 and 12, 2 and 6, 3 and 4. So 4 is the largest one that's common to both. So you want to take out the biggest factor that both numbers are made of. So let's do another one. Let's suppose I gave you 15 and 10. The greatest common factor would be 5, right? 5 is the biggest number that both will divide, or you can divide out of each of those. So those are pretty basic. Again, it's possible. Remember, you could have, if I gave you 7 and 21, it's okay if one of them is the greatest common factor. So in this case, 21 divides by 7, so our GCF would be 7. Okay? So those are pretty basic. So let's do some now if we have variables. So if I gave you x squared and x to the 5th, the greatest common factor in these cases are going to be whatever the smallest exponent is. And the reason for that is if you think of x squared, that is the same as x times x. X to the 5th would be the same thing as x times itself 5 times. So you can see this one has 2 x's, this one has 2 plus 3 extras. So 2 would be our greatest common factor. So with letters, you always pick the smallest of the exponents that are the same. So if I gave you y to the 3 and y to the 7, your GCF will be y to the 3. If I gave you x squared, y to the 4th, and x cubed, y, so in this case you pick the smallest of the x's, which is x squared, and the smallest of the y's, which would just be 1y. Okay, so you get the idea. So now what we're going to do is figure out how to do greatest common factor in terms of factoring. So what you want to do is, in order to do common factoring, the trick is you basically want to remove the GCF. So you want to figure out what the greatest common factor is, remove it, and then you want to divide each term by the GCF to figure out what's left over. Okay, so let's do a couple examples of those. So if I gave you 4x plus 2y, the GCF is 2, right? Between the numbers, 2 and 4, 2 can come out. Between the letters, we have x and y, nothing would be common. So in this case, 2 is our GCF. So basically then we just have to divide each term by 2. So 4x divided by 2 would be 2x, 2y divided by 2 will be 1y, and that would be our equation with a common factor taken out. So let's do another one. Let's suppose I give you 3x squared y cubed minus 6x to the 4th y squared. Okay, so in this case you want to figure out what your GCF is. So the greatest common factor between the numbers will be 3, right? 3 goes into 3 and 6. For our x's, we have an x squared and x to the 4th. So the smallest one will be x squared. For y's, we got y to the 3, y to the 2, so the smallest one is y squared. So that's what we want to divide by. So we want to divide each of these by 3x squared y squared. And then our leftovers, once we divide by that common factor, you can see in the first one, the 3's cancel, the x's cancel, x squareds cancel. All we get left over is 1y, y to the 3 divided by y to the 2. And then for the second one, we have 6 divided by 3, so that'll be 2. We have x to the 4th over x to the 2, so that'll be x squared, and our y's cancel, and we're done. What you want to do when you're doing this kind of factoring is you always want to look at what's left over in the brackets to see if you could go any further. because if you could, that means you didn't quite take out the greatest common factor. So when you look at this, if you look at the first one, we have 2x plus y. There's nothing common between those. We know we did it right. Same thing with the second one. We look at what's there. We know we did it right. Okay? So when you're doing these questions, it's worth your time at the very last step just to double check to make sure you don't mess that up. Okay, let's do one more. So let's suppose I have 8a squared b squared c plus 4 ab squared c cubed minus 2 a cubed b squared c. Okay, so it doesn't matter if we have one term, two terms, three terms, you do it the same way. So our greatest common factor between 8, 4, and 2 will be 2. And then do your a squared, your a's. We have a squared, a, and a cubed. So a to the 1 will be the smallest. We have b squared, b squared, b squared. So we all have b squareds. And we have a c to the 1, c to the 3, c to the 1. So that'll be c to the 1. So we want to divide each of those out. So 8 divided by 2 is 4. A squared divided by a, so we have 1a left over. B squareds cancel, c's cancel. So that's it for the first one. The second one, 4 divided by 2 will be 2. A's cancel, b squareds cancel, and then we have c to the 3 divided by c. So you can see sometimes it's a little bit tough to do this. So that's why it's a good idea to write that greatest common factor underneath. So 2a b squared c. So you can see we canceled, all we got left was a 4 and an a, the rest were gone. Same thing for the second one, once we divide by 2ab squared c, we got 2, and then just the c squared, and do the same thing for the last one. So 2 divided by 2 is 1, so we just have 1, a squared, right, a cubed over a will just be a squared. We don't need to put the 1 in there, but you can, it doesn't matter. So a squared, the b squareds cancel, the c's cancel, and we're done. So that would be our final factored answer. Okay, one other type we're going to look at is difference of squares factoring. And a difference of squares involves always just two terms, and we get things that we can't common factor. So we have two terms like this, x squared minus 49. So you look at it, there's no common factor, so we can't take out a common factor. But we do know that we can still factor this if we, basically what you want to do is you want to look at square rooting both terms. So if you square root x squared, that'll give you an x and an x. And if you square root 49, square root of 49 is 7, so that'll give you a 7 and a 7. And the reason we call it a difference of squares is one's a plus and one's a minus. So the trick to this one is just sort of knowing the format of these, because if you were to FOIL this out, you'd get x squared plus 7x minus 7x minus 49. So it's those two middle terms being one a plus, one a minus, they cancel, so we know that we get the right answer. So the shortcut with any of these is to just simply square root both terms and have one as plus, one as minus. So if I give you, let's do another one. Let's suppose I give you 4x squared minus 9y squared. Still do it the same way. Just square root both sides. So our answer then is square root of 4x would be 2x. Square root of 9y squared will be 3y. So you'll have 2x plus 3y and a 2x minus 3y. Okay, so you just get one of each, one positive, one minus. And let's do another one. So let's suppose I gave you, let's go 9a squared b squared c squared minus 36 d to the 4. Okay, even though it looks weird, you can still square root them. So square root both sides. So we would get square root of 9 is 3. A, B, and C for both. And when we square root 36, we get a 6. Square root of d to the 4th. The trick to there is, remember, d to the 4th. You square root that, that'll be d squared, because d squared times d squared you'd have 2 plus 2 would give you the 4. So d squared is the right answer. So we'll have 6d squared and minus 6d squared. Okay, so it doesn't matter whether you have numbers, letters, whatever, as long as you can square root both sides, you can then do a difference of squares factored. So the last type, let's just do a couple quick examples, is when they're mixed together. So what you want to be able to do is be able to do some common factoring. So if I gave you a question like that, you want to go through a couple of steps in your head. First of all, you always want to look for greatest common factors first. And if you can do that, do that. And then the second thing is then look to see if you can square root whatever's left over. So in this case, do we have a common factor? We do. We can take out a 2, and we can also take out an x. So once we know that the greatest common factor is 2x, we want to divide by 2x for both of them. Okay, so 32x cubed divided by 2x will just be x squared. 32 divided by 2 is 16, and the x's cancel. So now you can see we're close. We've common factored it. Now you want to just double check is, can we square root what's left over? So square root of x squared and square root of 16. Yep, that'll work. So then our final answer is 2x. Square root of x squared would be x. Square root of 16 is 4. So we'll have x plus 4, x minus 4. And that'll be our final factored answer. Okay, let's do one more. Okay, this one looks too easy, when sometimes too easy is too good to be true, and that's what happens in this case. So a common mistake people make is they square root both sides, so they go x plus 2 and x minus 2. But the problem is, when we actually were to FOIL this out, you'd have x squared plus 2x minus 2x, which would be the 0x, which is good. But we'd have 2 times negative 2 would give us negative 4. So the problem is, when you do these ones, that has to be a negative, right? We can't solve it with a plus. So that means if you have a plus, there are no factors, we just say that no factors. We can't do anything else. Okay? So be careful with those ones. They'll trick you every once in a while. So let's do one more that will work. So let's go 16. Actually, let's change it up a little bit. Let's go 18a cubed b minus 8ab cubed. Okay, so when you look at it, can't square root it. Those numbers don't square root. So you always want to do your GCF first. So can we take out a greatest common factor? We can take out a 2, we can take out an a, and we can take out a b. So when you divide those by 2ab, you see we get a 9a squared left over on the first one. Divide by 2ab there. We get a 4b squared with the second one. So now we can square root both of them. So our final answer is 2ab times 3a minus 2b and 3a plus 2b. So it doesn't matter whether you put the plus or minus first order, it doesn't matter. You just need to remember the common factor and then do the square root factoring second, if possible. Sometimes you'll just get common factoring, sometimes you'll just get square root, sometimes you'll get both. And that's all.